Hello friends, I am Dr. Giriraj Sharma, consultant neonatologist, and today we will discuss about different ventilator alarms and their troubleshootings. So first, you must have seen there will be one alarm of low pressure alarm. So low pressure alarm will be there. So in air and oxygen will go at high pressure. But if any compressor failure is there or any leak is there in line or there is decreased pressure in the manifold oxygen cylinders or leak in the central line, then there will be pressure delivery will not be sufficient here and ventilator will give low pressure alarm. Or sometimes leak will be there in circuit also, that will give low pressure alarm. So we have to check first circuit if there any loose circuits are there, some disconnection is there, any central line leak is there or not, or compressor is failure is there or not, or cylinder pressure is low or not. So these things we have to check in this. Second is low FiO2 alarm or high FiO2 alarm. So when it happens, so here this is the blender, this will mix the gases and deliver to low pressure chamber. Here FiO2 monitor will measure the FiO2. Okay, so this is giving, here we are setting the FiO2, required FiO2. This is FiO2 monitor is measuring the how much is delivering. So if there is discrepancy between the set FiO2 and measured FiO2, then there will be FiO2 alarm. If this one is higher than this, more than 5%, then there will be high FiO2 alarm. If this one is lower than this, so there will be low FiO2 alarm. If there is difference of more than 5%, then it will alarm. Then we have to check either blender is faulty, FiO2 monitor is faulty, oxygen sensor is faulty. So we can check in this limb by FiO2 meter. FiO2 meter we can check how much actual FiO2 is delivered, and then we can detect that FiO2 monitor is not functioning or what. Third is high pressure alarm. So when high pressure alarm will come, when circuit pressure increases, when there is increased pressure inside the circuit, then high pressure alarm will come. So why it happens? If there is increased secretions in the ET, if secretions are more in the ET, or baby is fighting with ventilator, like asynchrony is there, then there will be increased pressure inside the this circuit. If there is any condensation are there in inspiratory circuit, condensation are there, that also. If there is any kink in circuit, if any kink is there in ET tube or circuit, that also can increase the pressure. So these are the things we have to check. We have to remove the condensation water, we have to do suctioning, and if any kink is there, that we have to see. Fourth is low minute volume alarm. Low minute volume, that net volume, tidal volume is not delivering to the baby. So any alarm is there, first we have to see the baby, then we have to go to circuit and then ventilator. So first is low minute volume alarm. Maybe baby is not generating enough spontaneous efforts. Okay, so that's why flow sensor cannot detect the small spontaneous efforts, and that will not give signal to the microprocessor, and breath will not be delivered. So breath not delivered means minute volume will be low, breath rate will be low. That's why minute volume will be low. So if poor spontaneous efforts are there, or flow sensor is faulty, so that is not detecting the spontaneous breaths, that's why breaths are not delivered. Third, if there are any loose connections are here, if loose connections are there in circuit, that also will be tidal volume delivery will be less. Or if there is peritubal leak, around the tube size is less, so expiratory tidal volume will be, leak will be there, then also there will be low tidal volume delivery, okay, because of leak. Next, you must have seen high respiratory rate alarm. So high respiratory alarm could be because of the poor lung condition. Lung condition is very bad, compliance is very poor, so baby will breathe more, tachypnea will be there if lung compliance will be less. Second, if you have set settings are inadequate, you have set pressures are low, tidal volume is low and rate is low, then also baby will breathe more, tachypnea will be there, and high respiratory rate alarm will be there. And if you have set highly sensitive trigger at flow here, if you have sent highly sensitive trigger, that will detect very small breathe also, and that will give feedback and breathe will be delivered. So tachypnea will be there. So that also one thing. Other causes are tachypnea could be there, like pain, fever, and like tube block also can be there. So that can cause high respiratory rate alarm. Next is no pressure delivery or pressure gauge is not moving. When ventilator delivers the PIP, the pressure gauge is moving like this. If pressure gauge is not moving, no pressure is delivered, nothing is showing on the display, no PIP is delivered, no PIP is delivered, means expiratory wall assembly is faulty. This expiratory wall is not moving properly. So means here some moisture could be there, some rusting could be there, and here we have to check the expiratory. We have to open the expiratory wall and we have to clean, or we have to call the engineer to open this expiratory wall and we have to clean it. Next, different humidifier alarms will be there. Here many humidifier alarms are there. Like here heating probe will be there, here temperature probe will be there. Here we have to connect the heating probe and here we have to connect the temperature sensor. Temperature sensor will be connected to the inspiratory limb, like here proximal and distal, here distal, and heating probe we have to connect at the inspiratory limb behind. So if these connections are loose, of heating probe and temperature probe connections are loose, then there will be alarm will be there. If here these connections are loose, proximal or distal, then can be alarm. If water level is low, water is finished, then also will be alarm will be there. If temperature is too high, sometimes will go more than 41 degrees Celsius, then also alarm will be there. So we have to fix these probes, these fix properly. These should not be loose, we have to fix properly. Water should be filled. Here one distilled water filling chamber, like here port will be there, we have to hang the distilled water bottle and this will suck automatically distilled water. Next is disconnection alarm. If circuit is disconnected from anywhere, from here ET, sometimes in here at Y piece it is disconnected, sometimes it at any this at the level of humidifier it will be disconnected, sometimes these probes will be disconnected, like proximal or distal temperature sensors will be disconnected. So if any disconnection is there in circuit, then disconnection alarm will be there. So we have to check the circuit connections properly. Next is power failure alarm will be there. So if there is electricity interruption will be there, then power failure alarm will be shown. So for that we have to check the electricity supply, battery backup we have to check that battery is charged or not, and we should have the backup of the UPS and generator also. Thank you.